one thing to consider if he's intending to buy a new computer for this anyway, is look at the cost differential between the levels of the RAM. It may not be worth trying to stay too small because the price curve is pretty flat below some particular level of RAM. So don't push the RAM value down from what their standard is if it's not going to save you any money.
He looked at 8, I believe, and then he looked at 16. And 16 would virtually, apparently double the price of the computer. So he was cool toward that.
Okay, folks, so we should be live on YouTube, and I just shared the link in the chat here inside Zoom. Give it a try. Let me know if it's working.
Okay, let me check it out here. Well, we need someone to say something so I can check the audio.
Well, I was going to ask Elliot if does that duplicate the chat on YouTube, or
So sounds like you broke up for a second there, Kurt. There is a chat on YouTube, and I don't know that we can turn it off. We can choose one chat over the other and ask people to use that.
I was going to ask Elliot if does that duplicate the chat on YouTube, or
It's a 20-second delay so that we can bleep all the 4-letter words. So
Yeah, I verified that the sound is coming in properly on YouTube now.
There is a chat on YouTube, and I don't know that we can turn it off. We can choose one chat over the other and ask people to use that.
Does that duplicate the chat on YouTube, or
It's a 20-second delay so that we can bleep all the 4-letter words.
Yeah, I verified that the sound is coming in properly on YouTube.
There is a chat on YouTube. Do you know how many folks we're going to have on YouTube? Is it going to be a pretty good crowd?
No idea.
Okay.
You know, I looked at YouTube. I didn't see a chat there. I went searching for it on the YouTube.
It's a 20-second delay so that we can bleep all the 4-letter words.
If you
Maybe
full screen,
you have to
it may
be
disappear.
logged in to get the chat to go.
That'd be a pretty good crowd. Okay.
You know, I looked at YouTube. I didn't see a chat there. I went searching for it on YouTube.
If you full screen, it may disappear.
Logged in to get the chat to go.
You know, I looked at YouTube. I didn't see a chat there. I went searching for it on YouTube.
If you full screen, it may disappear.
Elliot, if my audio starts to break up, I'll just my other laptop, I don't have video working on it, but the audio seems to work okay on there. So we might have to make that decision
Yeah, you just went quiet.
in time. But sometimes my audio breaks up on this one.
Yeah, I lost maybe a 30 or sentence there.
Okay, well, let me log in from my other machine and I'll just do audio.
Okay, okay. I think you can assign a still photo of yourself in Zoom if you want to have a something that's not just a gray box.
Okay.
Dropped it, the state prosecutors. All right, well, back in with audio only, which I might have to go with. I'm not sure what my problems here are, but this is a little bit better.
Yeah, no, it sounds better. Good.
Okay, I've sent an announcement with the live stream link to the mailing list. I also sent it out directly to Bill Ricker, and I added it to the Blue website, both to the homepage and to the calendar entry for tonight's meeting. I also did
Sounds like
send it also to our RSC channel. So I guess everyone should know it by now.
somebody's got a bad ground on their either their headphones or their microphone.
Yeah, I thought I would mute all when we get started, and then people can unmute themselves as needed to ask questions. That usually works pretty well.
Oh, okay.
You're referring to that high-pitched whining noise?
Yeah.
Actually, I have UPS in my server rack where the battery's complaining that it wants to be changed.
Oh.
Let me mute myself and see if it goes away. I have a feeling it might be coming from my speakers.
It'll go away as soon as I mute myself. See?
Oh, yeah. Mm-hmm. So I'm innocent.
Okay, I'm going to share my screen here and get started. And then Kurt, I assume when you speak, you'll share your screen and someone else will be picking up the student cluster presentation. Is that right?
Yeah. In fact, I just have URLs, so I'll just put the URL to my presentation in the chat box, and then
Okay.
I'll talk over it. And then I think there's 4 or 5 folks coming from the BU HPC group, and 2 of them
Great.
wanted to talk, but they're not going to take more than 30 minutes, I shouldn't think.
Yeah. Okay. Okay.
I'm going to have to leave after a little while. I have another meeting that will be starting.
Okay. I've got a few windows up on my screen, but I assume all you're seeing is the Chrome window with my slides, hopefully.
Yeah, just the slides. It says the agenda.
All right, well, we're at the top of the hour, so I think we'll get started. I'll mute everyone, and if you do have a question, feel free to unmute yourself and chime in. We don't have terribly too many people on the line here, so I think that'll work pretty nicely. And I don't know if one of you folks on the line has a YouTube tab open, but if someone does indeed send some chat questions on YouTube, hopefully one of us will see it and can chime in and relay. I'll keep muting people as they join. Okay. So yeah, thanks again for being with us this evening. This is kind of a group event. It's the Boston Linux and Unix users group, as well as the Boston HPC and GPU meetup group. So hopefully we'll have some interesting cross sections here to talk about. I'm Elliot Eshelman. My day job is HPC at Microwave, where we design and build on-premise HPC systems. I'm going to talk a little bit about some of the recent events now that everything has been virtual. And then we'll have Kurt from MIT and some of the students from BU presenting on the student cluster competitions, which typically happen about now in June usually, and then in November of each year. So it's certainly different for them this year. Okay, so I'm going to talk a little bit about some of the HPC events that have been happening in these last couple months, all remote. You know, we were all thinking we were going to get to go travel a little bit this year, and it's not looking that way. But some interesting benefits to this remote is that I think some of us are getting to attend events that we don't usually get to. I don't usually get to attend ISC, which is held in Europe. So, you know, some pros and some cons, certainly. Okay, well, I guess we'll start with the obvious. COVID. It's yeah, maybe an unprecedented challenge for some of us. And you know, computers can't solve this problem. But it's been interesting to see just how much the HPC community has come together to try and tackle some pieces of this problem. What can be solved just you know, through computers and through research. So the Riken system Fugaku, which we'll talk about a little bit later, they came online a little early to help with some of the computational challenges around COVID-19, as well as most of the United States Department of Energy HPC systems, which some of those are not usually very easy to get on, but it seems like all these centers are trying to make it a little easier for researchers to get compute time if they're working on COVID. Same at Argonne, which is another DOE lab. They deployed some of the new NVIDIA systems early so that they could have the latest hardware for tackling some of this compute. I know that many vendors are participating. I know IBM, Intel, AMD are donating time or resources or people hours towards this problem. If you go look, there is so it's called the COVID-19 HPC Consortium. You'll see research centers all over the world that are collaborating and working on this, and you can apply for research time. There are software tools you can get for free. It's really everyone's coming together. And then of course, Folding at Home, which might be popular for some of you, they've been running this too. And it's been interesting to see that work. So they were, some of the folks running the Folding at Home were looking at the COVID molecule early, I think in March, and roughing out some of, you can tell I'm not a chemist or biologist, but they were roughing out the spike, I believe, and the way it moves and interacts with the human cell. And then at ISC, they did run a focus session on some of the ways that these different centers are helping to work on the COVID problem. And I have quite a few links in here, so I'll share my slides later, and you can all click through the links. So the whole conference is available for free, essentially. You can go to these links on YouTube and you can watch 140 videos. Some of them are from vendors, some of them are from HPC centers, or HPC research papers being presented. There's a lot of material. We're all spending a lot of time in front of our computers this year, I know, but there's a lot of material from this conference and others that you have access to. So definitely check it out. And one of the sessions you'll find on there is in regards to what some of the worldwide centers are running as far as trying to tackle COVID. And I know for ISC in particular, there were still some bumps. We're still figuring out some of these remote events and online events. I know it was hard for some people to find the ISC streams and some of the registration. Just the way the ISC webpage worked was a little confusing for me, certainly. I had some people tell me they were having difficulty finding what they wanted to find. And I heard from some that the time differences were a challenge, which of course, if we were traveling, obviously we'd have jet lag. But I know there were some people that woke up at 2 a.m. to attend some live sessions. And I know there were some people saying, oh, it was definitely worth it. I had no problem waking up at 2 a.m. To watch a live session, but I know other people that did not work for. And the student cluster competition did indeed occur. Normally, all the students, travel over, they lug a whole bunch of gear with them. It's a whole adventure. But this year being remote, they were using online compute resources, so kind of like cloud resources to do the challenge. So that was different, and it sounds like it will be similar. We'll hear from them later on the next student cluster challenge. But ISC running, they still did go through the new list of HPC systems. So 2 times a year, they update these lists with what are the most powerful and most efficient systems. What's particularly unique here is just how well this new system performed. So the institution is named Riken. It's in Japan, and their new cluster is called Fugaku. And you'll see in the first bullet point there, it's over 400 petaflops, which, if you need a frame of reference, that's more than 2 times larger than the US's. I think it's nearly 3 times faster than the US's system, which was #1 before this. Similarly, it blew everyone else away on HPCG. A lot of people use those first 2 bullet points as kind of bookends on the capabilities of an HPC system. So having #1 on both is very indicative. And then, just going down, they got #1 on Graph 500. They got #1 on HPL AI 500. So this is a very well designed system, and it's a system that doesn't have third-party accelerators, right? It doesn't have like an FPGA or a GPU in it. So I think we'll be talking more about this. There's a great guy who's working at Georgia Tech right now, who's going to give our HPC group a presentation in August, where he's going to do a deep dive into some of this. But it's a very impressive system, and from the last bullet point here, it's a very efficient system as well, in that it's close to the top of the list on the Green 500, which means amount of compute performance per watt consumed. It's very efficient. There seemed to be a little confusion on that, though. I saw a couple online publications posting it as like #9 or #7. I don't know if there were some early numbers that were a little less efficient and then they tightened it up. But this was apparent. This was what was posted during ISC, was that it was #4 on the Green 500. And then turning to some vendor news, Intel dropped a new set of CPUs. These are Intel Xeons, which probably most of you have heard about. They're server CPUs. What's different is that they're only made for big systems, 4-socket and 8-socket systems. So you can see here in the diagram, there's 4 CPUs connected by the Intel UPI link. What's special about these is that they're doubling down on that connection capability. The previous Xeons had 3 links per CPU, and you can see here each CPU has 6 links going out. So it's doubling the bandwidth between the CPUs in the system, which is important for efficiency as you're scaling up. So this makes it easier, in particular, to get to 8 CPUs, and I'll show that next. It's six channels of memory per CPU, quite a bit of PCI Express per CPU. It's Gen 3, which is kind of, in some ways, 1 gen back at this point. but a lot of bandwidth, memory bandwidth, PCI bandwidth, and bandwidth between the CPUs. And then this is what an 8-socket design would typically look like. So this is a pretty big system. Just to buy one of these, it's not something even that your average HPC center will deploy, or maybe they'll deploy a small number of them for specialty applications. There's a group at Harvard doing full earthquake simulations that has a system kind of like this. But it's a little bit specialty. Another interesting bit about this CPU is that it provides bfloat 16 instruction support, which is a bit esoteric, but is used for deep learning. So like apparently Facebook is going to deploy crazy numbers of this thing for deep learning. And the bfloat 16 allows them to do a reduced precision, which is not usually acceptable for HPC, but works pretty well for deep learning if it's done right. And on the software side, Intel is continuing with their heterogeneous software. So you'll probably hear quite a bit of talk about one API. We had a presentation from Intel on it in our group a couple months back. The idea is all these different architectures you see at the bottom of the slide, whether it's a Xeon CPU or an Xe GPU, which has been talked about, but you can't buy one yet, and then FPGAs, and some of the embedded devices, and the very specifically designed accelerators for deep learning from Habana. Those can all be, they all traditionally have had their own programming methods and APIs, and you have to do a lot of custom tuning. And the hope here is that, Sujata shared the link in the chat if you want to have a look at it. The idea is you can write to one API, and then you'll be able to execute on whichever hardware you happen to be running on. And Intel also has something called DevCloud. If you want to try it right now, you can get access in the cloud to some of the current generation hardware and try out your code, see how it works, and kind of start getting ready for when the big hardware arrives that has Intel CPUs, GPUs, and more.
Yeah, and another thing I can add over there is since our GPUs are not available, and since cross-platform is one of the things that is the main goal of one API, you can run one API in TPC++ code on NVIDIA hardware today, and there is a workshop happening on that. I can post a link to that, and I don't know, Elliot, if you have announced it to this group as well.
Yeah, please do. So there is a link on the front page of our Meetup page right now. There's a link to that Intel event later this month, and yeah, if you want to post it in chat as well, Sujata, that'd be great. So yeah, interesting days. We may have some time for discussion later. I'd like to hear what people think. And I have AMD here. They didn't seem to have a lot of news during ISC actually, but I thought it was relevant to mention just some rough speeds and feeds, since they've still been very active. There's been a lot of interest from the HPC community in their CPUs. They've had a couple of big wins on some of the really huge HPC systems in the US. So up to 64 cores per CPU, which is up to 128 threads per CPU. The clock speeds go up to 3.7 gigahertz, though you have to accept a lower core count to hit a clock speed like that. The big 64 core CPUs are usually more like 2.5 gigahertz. And then all CPUs these days will boost to higher speeds if they can. So they'll boost up to 3.9 gigahertz if they can. And those CPUs have good memory bandwidth as well. And they support PCI Express Generation 4, which is needed for some people. And I'll assign homework as we go. Again, I'll post these slides with the links, but there's so many videos you can go watch, hundreds of videos. There's 140 for ISC, and then there's a container workshop. There's a lot of cool stuff going on with containers for those that are interested in that. And if you don't know if you're interested, definitely check out containers like Google Docker or Google Singularity. They offer some really interesting capabilities. You don't have to manually install software a lot of times. For most common software,
you can find a container that's already got an optimized build of the software that you want, and you don't have to mess with it anymore. It can really make your life easier. And I mean, that can be a single scientific software application, that can be a deep learning application, it can be an entire kind of orchestrated cluster deployment. There's some pretty cool stuff going on. If you're doing more traditional HPC software builds, have a look at the SPAC tutorial that's coming up later this month. SPAC is a tool for automated software compilation. So if you're an HPC user and you're manually compiling code still, you might be kind of wasting your own time. It's really cool to use some of these new tools that will do automated builds, and they're built by really smart people. So you can have confidence in the builds they're doing. Architecture specific builds. So, if you run it on an Intel Skylake CPU, it will optimize to that CPU, and it knows how to build the underlying libraries, OpenBLAS or whatever it is, against the architecture that you're running in that system. So it's easy, and it works well, and it runs well. So it's pretty cool. There's another tool called Easy Build that I've had pretty good luck with as well. And then jumping over to NVIDIA GTC. So similar to ISC, there's a lot of videos, even more. You could spend weeks watching all this stuff. So I'd recommend, going to the link, searching on whatever it is that you need or you're interested in, and you'll probably find something regardless of what that topic is. There's all kinds of stuff. You can dig into the hardware, you can dig into the software, or just user applications. There's a lot to dig into. And I found NVIDIA GTC's event to be a little easier to deal with than ISC. I think that's because they have a bigger team, and they don't have ISC. They had to kind of herd a lot of cats, right? All the vendors and all the presenters and everything. NVIDIA had it was just them. They didn't bring in other exhibitors. So I think it was easier for them to keep a handle on things. But a lot of really interesting resources if you're a GPU user. And of course, their big drop was the new Ampere architecture, which is their latest GPU. It's a couple years in coming, and has some interesting capabilities I'll dig into briefly here, and you can certainly read more on later. The highlights are, it's got great HPC performance. It's nearly 10 teraflops right out of the gate. And with their tensor cores, if you're doing the right kind of matrix multiply, I'd say, you can essentially double your performance. So if you can leverage those units correctly with your particular math, you can get closer to 20 teraflops, similar for single precision. And NVIDIA has spent several generations now optimizing their performance for deep learning training and inference. So depending on what kind of neural network you're training or running for inference, you'll get anywhere from 3x to 20x speed ups over their previous generation GPU. There's a lot of material available if you want to find out exactly how they're achieving that. They're doing some very interesting optimizations with culling sparse matrices, and they're actually running compression in the L2 cache, which I don't know if that's been done before, but it was interesting to hear about. Each GPU has high bandwidth memory, so you're talking to the GPU memory at 1.5 terabytes per second, which again is, I think, a little bit unprecedented. And then they have some interesting new ways to split up each GPU, so you can have multiple users on each GPU, and a lot of bandwidth. So again, this harkens back to the PCI Express Generation 3 versus Generation 4. The new GPUs are Generation 4, which has twice the bandwidth of the older Generation 3 GPUs. And then NVLink is NVIDIA's proprietary link between GPUs, which again is also had a 2x increase in bandwidth with this generation. So you can now push, on paper, 32 gigabytes a second over PCI Express. From our testing so far, you get probably 25, 26 gigabytes per second in practice, but still 25 gigabytes per second out of a single device is kind of impressive to see. On the fabric side of things, that usually ties in with HDR InfiniBand or 200 gig Ethernet. And again, on those 200 gig interfaces, we're seeing about 25 gigabytes per second. So I'm impressed anyway. And then digging into the Tensor Core a little bit. So again, this is a special hardware unit designed for matrix multiplies, and it now supports a lot of different instruction types. So FP64, which is double precision, usually what's used in HPC. This is the first time that NVIDIA has supported anything like that. And then they have TF32, which I'll describe, BF16, which is the B float. So that's I guess an instruction that was first desired by Google for their deep learning. Intel has some support for it. Now NVIDIA has some support for it. I'll show you exactly what that looks like. And then you can also do these matrix multiplies on even like on integers, 8-bit integers, 4-bit integers, and even binary units, which I haven't seen how that's being used, but there might be some interesting applications of that. One important thing to note, if you're an NVIDIA user, is that on this new architecture, they're defaulting to this new TF32 instruction. NVIDIA says that they ran all the models they could on it in their internal systems, and they weren't seeing any accuracy losses, and so they went ahead and made it the default. So that is a change that may be important for some people to be aware of. And the sparse matrices support, which I mentioned before, allows them to get some interesting performance improvements. So this is how the Tensor Core operates. And in the previous generation with NVIDIA V100, they were using a full 32-bit instruction. And in the new A100 GPU, they're using a what looks a little bit like a 32-bit instruction called TF32. And here's what's going on. So this would be a full 32-bit FP32 floating point number, right? There's a sign for positive or negative, and then you have 8 bits for, I'm gonna get these reversed. You have 8 bits of range and then 23 bits of precision. And what TensorFloat 32 does is it combines the accuracy of a 16-bit number with the range of a 32-bit number. So you don't have very much precision, but you have just as much range as if you were using a full 32-bit instruction. And I know this kind of gets really esoteric. It is starting to come into use in HPC. So for those developing software applications, it's worth starting to think about some of these problems. I'm working with a group that is implementing a CFD code with TensorFlow, and it's really interesting to see how that's working. You could do some very interesting things. And down at the bottom, you'll see bfloat 16, which again, I think Google was the main driver of that originally. So bfloat 16 had the same range as a 32-bit number, but considerably less precision. And NVIDIA's kind of mixed, they're kind of in the middle now with better precision than a bfloat, better precision than a bfloat, but a lot fewer bits than a 32-bit. Thanks, John, for correcting me. It's the sine, the mantissa, and the exponent. And then again, same kind of Tensor Core unit, but with 64-bit instructions. And this is what may be particularly of interest to HPC users. On paper, you can get a 2.5x speed up if you can fully leverage the Tensor Core unit on an HPC application. There's no funny games with precision or accuracy here. It is a full 64-bit instruction that's going into that matrix unit. Here's what they're seeing today. And these are NVIDIA's own numbers published on their website, right? So they're showing for some of the common apps you may have heard of, little shy of 2x performance, in honesty, right? But we have seen that for any architecture, as applications get optimized, those numbers tighten up and they start being able to fully leverage the hardware. So that'll probably get better over time, as it would with any architecture. The other interesting bit with this new GPU is the capability called MIG, which lets them split up a single GPU into 7 slices. And in some ways, you might think of this as the first real kind of virtualization-ish capability in a GPU, because previous GPUs, you could kind of share them in certain ways between processes. There was less isolation between users and whatnot. But this looks like the first generation where you can really be sure that there's some actual hardware isolation between yourself and other users on the GPU. So it's more secure, it's more fault tolerant, and it's just, you know, for an HPC center that has a lot of users that might not need a full GPU, you can do some interesting things, right? A lot of people are using Jupyter notebooks these days where they might need access to a GPU, but they don't necessarily need sole access to a $10,000 GPU all the time, and they can do some development work on a slice of a GPU. It's going to be pretty interesting to see what's possible with that, I think. And it isn't just a 7-way slice. If you want, you can take, you know, a half of the GPU or a quarter of the GPU, and you can kind of mix and match these. So you could have a couple of 2 slices along with several single slices. Right now, they're mostly focused on Kubernetes for this. So Kubernetes is going to be the first one out of the gate that supports this kind of mixing and matching of GPUs. But Slurm isn't too far behind. So later this year, you'll be able to, you know, to log into a Slurm GPU cluster and say, I want 1/7 of a GPU or 2/7 of a GPU or whatever, and it'll schedule your job and you'll be good to go. So that'll be interesting, I think. I've seen it in use in EDU where they'll be running a lab. And you know, every student needs access to a GPU in the lab. They start up a Jupyter notebook, and each student can kind of do development work on a slice of a GPU. And then another bit of news that dropped was NVIDIA's HPC SDK, which in some ways is a renaming of previous tools. So if you know the name PGI, Portland Group Compilers, those have been kind of fully and officially folded into NVIDIA now. NVIDIA acquired them a few years ago. So the old, what was it, PG, C++, and all those compiler tools are now folded into NVIDIA's tools. And you can see here the various libraries they have. They have quite a few pretty capable math libraries, and then they've got debuggers and profilers, and they've got a new roofline analysis tool. So if you're using a GPU, you owe it to yourself to look at this if you're developing for NVIDIA GPUs, because there's a lot of tools. And I think some people probably don't avail themselves of the tools as much as they could. These tools are free as in beer, so to speak. So you can download them for free, but they're not open source. And then if you're actually looking at what hardware is available, there are single GPU cards. There are 4-way linked GPUs and 8-way linked GPUs. So if you are scaling up a job where there needs to be a lot of communication between processes, you want the 4-way or 8-way linked GPUs because they have bandwidth between all of the various GPUs. If you go with the card style GPUs, you can only have them in pairs, which means you can't get full communication between all 4 or all 8 GPUs. And that NVLink speed, again, was doubled in this generation. So you're now talking about 300 gigabytes per second coming out of each GPU. So it's extraordinarily impressive bandwidths that are going between those GPUs. And NVIDIA then has their own server platform, which is kind of an all-in-one appliance system. And this is an 8 GPU system. So it's got the 300 gigabytes per second between each GPU, each of the 8 GPUs. And then it's got, as you'll kind of see in the back, there's 10 network adapters. Each network adapter is 200 gig network adapter. So there's a crazy amount of bandwidth coming out of these things. And NVIDIA built themselves a large size cluster. And currently that cluster is number 7 on the top 500 and number 2 on the green 500. So it's very power efficient and very capable overall. So they took 140 of their 8 GPU systems and built them together into this cluster, as well as some 200 gig InfiniBand and DDN storage. DDN has been partnering with NVIDIA on some RDMA storage capabilities. So you can feed data straight from a storage device into a GPU without touching the CPU, which is, again, up and coming and kind of interesting. And breakdown for those of you who are interested in the comparisons. The last time I showed this, Radeon fared a bit better, and I'm sure AMD will be showing something new in the not too distant future, and that'll be interesting to see that comparison. But right now, NVIDIA's A100 is looking pretty solid, winning kind of across the board, so to speak. And again, I'll share this presentation so you don't have to dig through everything here. There's a lot of squiggly lines in this because all of these capabilities really depend on your application. Well, sorry about that. So depending on your application, you're getting anywhere from 10 teraflops to 20 teraflops. And we're going to have to see how these things nail down over time. Okay, and another interesting thing, this one is not available yet, right? We've had people asking, and we're going to have to wait a bit longer to see it. Probably by the end of the year, hopefully we'll see it. But it's some of the first merging of NVIDIA and Mellanox technology. So they've taken this new GPU, stuck it on a network card, and they think it's going to be most useful at the edge. It'll be interesting to find out. I think people are going to probably do some interesting things with it. So the exact GPU compute capability isn't quite clear yet. It's dual 100 gig E or dual 100 gig InfiniBand links on this card with a GPU with secure enclave and encryption. And the idea with that is you can deploy your application somewhere on the edge. And if someone steals it and runs away with the box, your software is encrypted, and as soon as the box loses power, those keys are lost, and they've got your hardware, but they don't have your software or whatever data was on the box. So could be interesting. And there are developer kits. So I know we have some fans of the Jetson in previous generations. There's a new one. I think it just launched last month, $400. So it's pricey as far as the developer kit goes, but capable. So it's got a Volta generation GPU on it, an ARM, 6-core ARM, 8 gigs of memory. It's got wired Ethernet capability, Wi-Fi, Bluetooth, and you can configure it for different power consumption. So it goes as low as 10 watts. And there are other form factors of this available. A lot of times people will build on this box and then go to an even more embedded version as they're scaling up, so to speak. And I've got homework here too, and so I'll share these slides. There's a lot you can dig from. Okay. So we've got a few minutes left, I think. I'm curious if anyone wants to bring anything up. I've got a few HPC discussion topics if no one has anything specific that they want to bring up themselves. So the floor is open. All right. So this is a question a lot of people have been asking themselves. I'm curious if anyone has strong opinions. Or what did I miss? Kurt, did I miss any important up and comers here?
No, not yet. I've got a little bit of a RISC-V announcement, but they're a long ways away from having anything in the HPC space, I think.
Yeah, it's interesting. I guess there's just a lot of momentum behind the the traditional options. I mean, I see quite a bit in my small
you.
sliver of the world that people just kind of go with what works and don't always. Well, I mean, it can be extra work to go outside of the norm too far. So I guess I understand that. So we'll
that
see.
in the NeoCortex presentation today. So I've got a little
Yeah.
bit of a breakdown of what NeoCortex is doing. So I'll give that at the end.
Mhm. Okay, great. Yeah, what I see is pretty much x86, right? We see a little bit of power and a request every once in a while for a couple of ARM boxes. But you know, it's been Xeon mostly for the last couple of years. Oops, and Epic is now starting to be of interest to some, although maybe not as many as you would think. Epic has some really impressive performance numbers, but even so, you know, some people are just really comfortable with Intel, and it might take some. Sometimes it takes a while for people to adopt something new. So it'll be interesting to watch as that continues. I know some of the U.S. centers, certainly in Europe, ARM is starting to take a bite, and obviously in Japan, ARM is taking a bite, so to speak, since their number one supercomputer is using the Fujitsu ARM. And then same on the accelerator side, right? We're starting to see a lot of options. Some of the Intel products are up and coming, but have already seen some wins in the US. So, for example, Argonne is going to be taking a big system that has the Intel GPU.
I guess Mike was cutting his own hair too, and then Mike finally went to the barber. Mike's hair looked really good with him
Someone's got an
trimming
open mic.
He would use that electronic thing.
My mute
Electronic thing?
powers are not working.
Oh,
Floby?
huh?
Floby?
I don't know what you're talking about. He would cut his own hair using.
Any
I'm gonna
feedback
call it
from the
buzz
crowd
cutter, I
on
guess.
accelerators?
And then he would like make his top.
Do you know about any other accelerators? Something outside of the GPU epistemology? Is there something that does, I don't know, crypto on a PCI card edge?
Crypto on a PCI card. Yeah, you would think there would be something. I don't know. I am sometimes a bit of a distance away from some of the non-traditional HPC. Oh, Sujata's saying QAT.
Yeah. So I don't know how many people know about that.
Is that a function built into a CPU or is that a separate device?
It's an accelerator. It's a separate device.
Okay.
Yeah, it's for crypto and encryption. I'm just trying to find the link for that. Hold on.
Okay, great, thanks. Kurt, I think most of the other accelerators that I've seen are a play on an FPGA. I know was it Texas Instruments that made a play with something, but I never heard where it got adopted, if anywhere.
I think there was some talk about being able to buy a discrete TPU card from Google.
Oh, from Google.
Yeah.
That didn't happen though, right?
No.
They gotta keep you paying monthly for your TPUs.
Yep.
Yeah. And another thing is, and I can't answer this because Codeplay is into specialized accelerators, and Codeplay is the one who's going to do the next workshop that I posted the link to on DPC++ NVIDIA compiler. So, if anyone is interested in that, you can attend and Codeplay will be there. You can ask that question. Or otherwise also, if someone is interested, I'll be happy to connect you with them.
Thank you. And yeah, most of you folks on the line here I think are members in the HPC Meetup group. That's probably the easiest way to find people. If you need to, you can send messages to other people in the group. Or even you can chat here, I think, inside Zoom. Okay. Well, I'm almost out of time, but This might be the biggest religious war of them all about how you're going to write your code, and I'm sure I missed some here. But these are usually what I see come up in discussion. One of these languages on some of the more traditional HPC systems. And,
Yeah.
yeah.
So OpenHPC, you know, that NVIDIA is really agnostic now between CUDA and OpenACC, as far as I can tell. It's like, you know, tell us what functionality you want, come to one of our hackathons, and we'll find a language for you. So OpenACC seems to be growing in popularity at MIT.
Interesting. Okay. Because it almost seems in some way there's a push away from that towards some of these, I don't know what you want to call them, more specialty languages like SYCL, and NVIDIA has their own version now that they released with CUDA 11, where it's just C. It's a new version of C++ that supports parallel operations. I honestly don't know it that well, but I hear less about OpenACC than I used to, and for quite a few of these accelerators, you can use OpenMP as well.
Yeah, so for those who are interested, DPC++ is built on top of C++ and SYCL, and that would run on NVIDIA hardware.
So, Jato, you think the DCP++,
DPC++.
is that going to be the most common language used for one API?
Yeah, one API is based on DPC++. Yeah. So we see a lot of adoption. I saw mention of FPGA. A lot of people are converting OpenCL code to SYCL and DPC++ right now. And there are developers who are also porting CUDA code to DPC++ because they want to become vendor neutral.
And so when you do that, you should be able to target an Intel CPU or an NVIDIA GPU or an FPGA or...
Yeah, and Intel GPUs when they come.
Yep. Okay.
Yep. But in the meantime, NVIDIA GPU. And since SYCL works on AMD, so it will work on AMD as well.
Cool. Well, I used up all my time, I think. And that's all I had to share. So I'll post my slides. I know I had a lot of links. Definitely go watch, like almost all those videos are on YouTube for ISC, so they're pretty easy to find. But there's a lot of cool stuff you can dig into.
Yeah, this was great, Elliot. It was a great summary of the event for those of us who did not go there.
Good, thanks. Well, yeah, I mean, and you didn't miss it because it's all on YouTube. So just, this weekend, just hang out on the couch and watch 140 videos.
Yeah.
Okay, so I'm going to turn it over to Kurt. I think you're going to send me a link, Kurt. Is that what you want to do?
Yes. I just put it in the chat window. The reason I'm doing this is I have, for some reason, ungodly bandwidth problems right now. And indeed, Elliot, if I do fall off the air here, just carry on.
Alrighty.
I'll be with you in spirit, if not in voice.
Yeah. Okay.
The good thing about all those links is the first chunk of the link I'm talking about is autonomous vehicles, and that's kind of what me and the undergraduates have been doing for a little while in the absence of other things. There's an increasingly tight association between autonomous vehicles, Linux, NVIDIA Jetson, and I'll walk through some of the things we've been doing lately to try to show you what we're doing and what, at least by my count, 24 other universities across the U.S. are doing. My first link there is the Indianapolis Autonomous Challenge. Now we've been involved, the BU students, a couple of MIT students, myself, have been involved with autonomous vehicle competitions of some variety over the course of the years.
the IGVC jumps to mind, the International Ground Vehicle Contest. Those aren't really the couple classes there. They've only recently opened up one called the Self-Drive Division. Now, those are vehicles that you might recognize. For a while there, they were these Polaris Gem golf cart style things. So certainly battery powered, like EVs, and then progressively more and more with some Linux box on there retrofitted in to bypass all the electronics and go straight to the automotives. So that got canceled this year. I don't think they plan on bringing back the 2020 competition. I think they'll just wait till 2021. A lot of those competitions have fallen by the wayside, but the BU students and I got in on one of the joint teams at the India Autonomous Challenge. We're on Team Pegasus. There's another MIT team listed, but I'm not quite sure what their involvement will be. I've read on their website that they've got other interests. They compete in this thing called the student. I think it's called. It's a student competition that's very heavily European schools, and MIT partners with TU Delft, Formula Student, that's it. And they may be spending more time with that and will not be able to participate in the India Autonomous Challenge. And that decision may be driven, yeah, there we are, there's Team Pegasus. I don't know if the only thing they really have for links there are links to people's white papers, which was our first deliverable. And now our next deliverable, we've had one since then, but our next deliverable will be in August, and that will be a demonstration of a functional vehicle. So you can see the difficulty with working on an autonomous vehicle competition when you don't have access to a garage or the other teammates. So we're doing as best as we can. We have weekly meetings, and in accordance with the rules of the competition, we're using their recommended packages, which is a ROS2. So robot operating system is what everyone wants to use in the Linux-based AV business. They're using a ROS2 form, which we're learning some of the peculiarities of. It's very easy to get smart on ROS, which is a superset that sits on top of your Linux, and it's very much of a publish and subscribe model. Like you'll spin up a driver for your LiDAR, and you'll publish that information, and some of your other daemons can read that information while it's being published. So it's very easy to get smart on ROS quickly, and we're getting smart on ROS too. There are some peculiarities with the new generation ROS. There's also an iROS, industrial ROS, which a lot of the defense contractors like to use. It's a little bit more secure, discrete. The packages are separated a little bit better. So I don't know much about iROS, but I am getting smart on ROS too. Now, in parallel to this, because we're big fans of sticking with the code bases we've already worked with, we're participating in this Project Aslan. So Project Aslan is an open source, open science way to get your code out there. One of the founding partners of this was a group that we've been working with a lot in Oxford in the UK, that Street Drone. So Street Drone had an open Street Drone source, which quite conveniently for us worked great on the Jetson, on the NVIDIA Jetson. NVIDIA Jetson is, as Elliot said, kind of parallels the NVIDIA discrete card product line. It stays about a year behind, but usually keeps up. As you saw, they have a Jetson now that has Volta cores on it. Not as many, and most importantly, tuned to low power. So that Jetson runs off of USB. I think the Volta Jetson runs off of USB, or maybe that's the last generation. So it's perfect for us if we're building a drone or an autonomous vehicle of some variety. Some little credit card size processor SoC or board that sits on top of your automation interface. That works great for us. Turns out a lot of other people are interested in that. Certainly in the very specific vertical of autonomous research in universities, having a Jetson-based electric vehicle is becoming quite popular. There's a company that's being funded by Renault. Renault makes the Twizy, which is pretty popular in the UK. They also make a number of other vehicles that look like the Twizy. The Twizy looks a little bit like a Mercedes smart car. It's about that same form factor. You may have seen some in the city of Cambridge. There's a company that has Twizzies. It's basically the blue bike of vehicles. You can park it anywhere in Cambridge, and then just it's kind of a combination between the cars that you can, like the Turo car, you can leave a street anywhere, and then you just wave your super heterodyne chip over the front windshield and get into it. Hasn't quite caught on yet anywhere else in the U.S., I guess, except San Francisco, because the Twizy is not only not great for the U.S., but it's certainly been discontinued. Renault has the Palm now, which is where they partnered with a company called OS Vehicles. So this will be the duct tape of the people who want an autonomous vehicle for research and development. Whether it sees any time on the streets of Massachusetts, I don't know. We're pretty well set up for it. City of Boston has an autonomous zone, and they've published that report there on where you can drive your autonomous vehicle in Boston. As you might expect, it's over near Mass Robotics and Autonomous Ride and Waymo and those other companies that are over there in the Innovation District. And the city of Cambridge is zoning a whole section, potentially the whole city, for 20 miles per hour. And that'll be great for electric vehicles and autonomous electric vehicles. Where the sweet spot is between having a fleet of EVs or AVs to either deliver people or Amazon boxes, I'm not sure. There's been plenty of false starts. I'm hoping this Project Aslan, because it's also targeted at a 20 mile per hour maximum speed, may have a little bit more traction. So I'll keep it posted on that. I'm really quite fascinated how quickly the code bases for Jetson-based ROS/Jetson/ Renault interface has really taken off. So then I listed a couple of the AUV New England conferences. We have AUV SI New England has, you can probably scroll down to, where is that one? The AUV New England.org has the Robotica conference. Yeah, the last one on the AV topics. No, there you go. They have the Robotica conference. Now, the Robotica conference used to be here every year at Draper, but what they're doing now is they're breaking up the presentations across, the next couple of months. They had one last month. This guy up at University of Waterloo, Darwin AI, he presented his topics, and I think that's what they'll start doing from now on, is having these lectures spread out over the course of a number of months on this website. Now, the good news is, Robotica, you used to have to pay and block out a weeknight to go to, and now it's free online for all comers. You just register, and then you get to, it'll be smaller attendees. You get to interact with the speaker that way, which works out a little bit better, I think, for the speakers. The other section I have on the AV topics is a link to the MIT Industrial Liaison Program conference. It's right, that little block there that says ilp.mit.edu under AUVSI conference. So the first day of the ILP conference, we had Professor Karamon from the Flight Goggles Lab talk. That was the first day. There's a lot of good stuff at the Autonomy conference, but I was really impressed with that first day. Professor Karamon talked about his chip. So he has a chip that he puts onto his drone boards, and his drone board can also fit as a daughter board on top of Jetson, and he talked a little bit about how they're using his flight goggle software to compete in the Lockheed Alpha Pilot competition. Now, it was supposed to, they were going to do a semis and a finals, and that was supposed to sum up here this month or maybe next, but they've postponed it. So they'll probably have the Alpha Pilot competition 2021, and maybe they'll be back on the same schedule that they were on for 2020, not just delaying 2020 for 6 months, but being back on a 2021 schedule. So I'll keep you posted on that. Last time I went to the Alpha Pilot site, it said it had been postponed, but now it's definitely canceled for 2020. And but meanwhile, I can go to the flightgoggles.mit site and download the SDK and work on the navigation tools. So he's hoping that the virtual navigation and the remote vehicle will work in lockstep, so that the delay will not significantly change the performance. I think what that means is, if you've got a course and you're going to need no less than 5-second timing between your joystick and what the remote vehicle does at that course, then they'll design the course so that you can pivot in 5 seconds and then at least not get into an accident. There'll be it's not clear to me how they'll stagger that off, but I'll certainly know more on Alpha Pilot before they open that back up in 2021. And then I just wanted to talk about some of the other upcoming conferences that Elliot didn't hit. The big flagship IEEE conference at MIT is High Performance Embedded Computing. It's now actually High Performance Extreme Computing because of the overlap now on the various topics that are hitting us. A lot of people have changed the focus of their HPC conference now to incorporate HPC and AI to capture a lot of the discussions that are going on with the low precision tools, hybrid tools. You know, a lot of people want to use the machine they bought for native double precision math to do some of these other applications, TensorFlow, BERT. They want to be able to use their double precision gear for multiple activities, and AI performs much faster at lower precision or with iterative refinement or some of these other tools. So a lot of conferences like HPEC and what used to be called HPC on Wall Street is now called HPC and AI on Wall Street, to be able to incorporate some of this new hardware into. Yeah, so they still have the March announcement here. I have to figure, since this is in New York City, that the September event in New York City, HPC and AI on Wall Street, will be delayed. But the reason they haven't taken that announcement down yet is because it's actually starting to look like there might be a lot going on in New York City in September. I'm not sure Massachusetts will move as fast as New York, but they may go ahead with this conference in some limited attendance perspective, but with also with a remote back end. This is a pretty good conference to go to. You'll see a lot of codes there, a lot of vendors there that you don't see at supercomputing and some of the other HPC conferences. It's gotten much bigger. Tabor, which owns HPC Wire and some of the other news outlets, has taken over this conference now. So they've moved it to a bigger hotel. They'll probably broaden some of the areas. It's nominally, I believe right now, a day and a half conference. So maybe they'll extend the format there too. I wanted to tell folks, possibly folks that go to ISC a lot, that there is another European conference, PASC, PASC 20 is postponed, but I went to PSC 19. It's the week after ISC, and they kind of want people to come down to Switzerland out of Frankfurt. There's like a day between ISC and PASC, and it's a lot of the same presentations. The national labs from the US have a lot of presentations there, so there's a lot of content. Anything you couldn't see at ISC, they have at PASC. I also have listed there another couple of the automotive conferences. I think I'll get with some of the students online and ask them if they want to attend. These are all virtual now. They were listed originally as attendee, but like the automated vehicle symposium, that's $159 for a student. So I will definitely pay for a student to attend that if they're interested in. It's about a 2-day. It's a 2-day remote conference, mostly topics. There seems to be a lot of overlap on certain subject areas. Like you'll get 5 lectures on what level of automation we should allow on the streets of the United States. Should we actually allow a human to jump in at level 4 and take over the automation in a stressful situation? That's a big topic right now. If your automation starts choking on you, is it really a good thing for the guy in the back seats that's been reading the New York Times to jump in and take over driving at that point? And then down there at the bottom, I do have a couple of miscellaneous links. I'm on a couple of lists that are constantly out, job listings, and the national labs are hiring like crazy right now for people with AI and computer architecture and HPC and design chops, and they're not really being too picky about having to move to California or to New Mexico. The verbiage implies that, they say location, Berkeley, California, but they're being pretty negotiable on some of these. Apparently, those are what I'm getting in my emails. So if you see something there that has your name on it, there's a lot of quantum computing going on the left coast. There's a ton of computer architecture. If you know anything about some of these higher level chip design languages like Blue Spec or Chisel or Scale Out, they have positions for that, and I can certainly see how to do that remotely. The only other links I can probably tell you about down there, Radio Free HPC has a discussion with the direction that RISC-V is going in the HPC space. Now, that was going to be a big presentation at ISC, where they've got a new task force, a new working group that's looking at HPC. I think they may have missed their window. ARM has jumped into HPC, as Elliot told you, with both feet. I sat in on that CMU, the Pittsburgh Supercomputing link there is to the Neo-Cortex lecture, which was earlier today. They're going to post that online. Not just the presentation, but a lot of the links. Neo-Cortex is built out of these interesting Cerebrus, they call them processors, but they look more like a sheet of paper. They're so big. They use, I kind of had to catch my breath when he said, yeah, our processors use 2 kilowatts each. And he's got 2 of them. So these Cerebrus, for those of you that saw that $1 million doorstop they had at SC19 in Denver, I'm really impressed at how quickly they've moved with that, and they're going to give people, academics, early access to the Cerebrus CS1 based supercomputer. It's also got well, like I say, as soon as they post the presentation, it'll answer all of your questions. It's got 18 gigs of SRAM, everything, every trace of silicon. It's really a remarkable design. I think that's the natural progression of where things may end up in the HPC business. If we can consolidate everything onto one big piece of silicon, move all of our discrete chipsets off of the motherboard, and introduce it as an IP block into the silicon, and I don't know, 65 nanometer. Well, no, it'd have to be less than that. It'd have to be some contemporary fab process, but just a lot of layers, and either 2+1D, or maybe they'll finally have 3D down by that. You can certainly do that with HMC or hybrid memory cubes, some of these new technologies. It looks like all of the building blocks are there, and Cerebrus might have nailed it. That'll be really interesting to see if this is the way of the future, and we'll find out by running our TensorFlow and our PyTorch codes on the NeoCortex cluster. So those are kind of all of my links. I can certainly speak on, if you want to catch me offline, I can certainly speak on some of those individually. I wanted to leave a lot of time for the BU students because they've been fastidiously working on Sundays since the end of the semester. So they can probably bring us up to speed on a couple of their topics. But if you want, I'll answer a few questions right now.
Well, if no one else speaks, Kurt, I'm curious for the Cerebrus systems. I mean, they're big HPC, right? That's like you gotta drop $1 million or more to get one, right? It's not for the masses yet, but you think maybe it will be for the masses at some point?
Yeah, and I wasn't quite sure on the architecture. I missed that slide. They were very, very chatty about certain aspects of it, and they certainly didn't imply that there was any NDAs. But I think they're using maybe a lot of integer, certainly a lot of single precision. I don't know if they've got some of the same floating point definitions that you described that NVIDIA uses. So I'm not sure about that yet. But I'll grab that. That was early in. They had the architecture guys speak second, so I'll check that when the slides come up.
Thanks. I'll second your recommendation for Radio Free HPC too. Those guys are pretty interesting to listen to.
Yeah.
Anyone else have questions for Kurt? Comments? Turn it over to the students.
Thanks.
Okay. Natalia, are you taking this one? Do you have a screen to share, or do you want me to pull up your slides?
Actually, I'll be taking
Oh,
over.
okay.
Yeah. Let me share my screen.
Okay, I'll stop mine.
All right. So, hey, everyone.
Hold on, Ben. We got you muted accidentally. See if you can unmute yourself.
Hey, can you hear me?
Yes, go ahead.
Okay, right. So I'm Ben, and Yuja and Norman are also here. So we're going to be presenting about a competition that we're planning to attend in the fall. Natasha and Quentin, they're also here. Recently graduated from BU, and they used to be our club leaders. Now it is us. So in the past, we've been to and presented at a couple of these meetings before, but for this year, we're hoping to make a regular appearance. So during the school year, we have meetings, weekly meetings face-to-face, but now due to COVID, we're not sure what exactly is going to happen. BU, like many other colleges, are kind of planning a choose your own adventure for the fall semester. So that's classes with like a hybrid approach, rotating between in-person but socially distanced learning as well as remote learning. And especially clubs will have limited meeting times and seating capacity. So what that means for us is we need to figure out whether or not our club can operate remotely. Planning for SC20, yes, we can do it remotely. We have been doing that. Club meetings, we've also been doing that remotely. Our Raspberry Pi cluster that we're still building, it'll be a challenge, but we can still do most of that remotely through SSHing into the cluster. So I guess really being remote allows us more flexibility and possibly higher attendance at club meetings, since there's no need to actually get yourself out of bed every Sunday morning. So the main thing that we'd like to talk about is SC20, one of the supercomputing competitions that we're planning on attending later in the year. So SC20 is an HPC conference that lasts for the better part of the week. This year it's being held in Atlanta. And as part of the conference each year, a student cluster competition is held during the conference. And this is the competition that we try to get into every single year. And lately we haven't been having much luck, but hopefully because of the changes made to the competition for this year, we'll be able to squeeze in. So the competition will be held remotely, but people who are teams who are admitted are still allowed to attend in person, which will be a club decision. And there's no more choosing hardware. Instead, we're given Azure credits and we have to pick our software stack. So actually, Elliot, to answer one of your discussion points from earlier, initially when we were first writing out our proposal for the competition, we were going to go with AMD EPYC. So our next system, we're going to choose that. We also took a look at the IBM Power as well as an offering from Oracle. But we decided on the EPYC because good price to performance, as well as pretty good AVX support, which would help us a lot for a lot of the parallel applications. So the application.
Are you going to be able to select EPYC CPUs from the Azure? Do you get to pick your?
What we're not sure about. The way the prompts were reworded, it sounds like they choose the system for you, and it's all about the software. But as I said, we're really not sure. Yeah, so application decisions come out in about 2 days. So fingers crossed, hopefully we get in. So the competition has 7 total parameters, but we prepared 3 of them that we'd like to talk about today. So I guess we can start off with Norman.
So for this application, the high performance conjugate gradient, it's a significant departure from the classic LinPack benchmark, since it uses more sparse data structures that have a very low compute to data movement ratio. And so this one uses sparse matrix vector multiplication, vector updates, global dot products, and local symmetric, basically a lot of math equations thrown at the processor to be able to see how good it's working at. And then a valid run needs to execute a large enough problem so that those data arrays accessed in that CG iteration loop don't fit in the cache, so that it would be unrealistic in a real application setting, but it would allow to show the best possible benchmark itself. And then this restriction only means that the problem size should be large enough to occupy a significant fraction of main memory, at least 1/4 of that space. And then they say that HPCG is going to be like the future in terms of what benchmarks could be used for HPC, and could be even better than LinPack in the future.
Okay, yeah, so that was the first of the applications, I believe, and then Yuja will be telling us about the biological applications.
Hey everyone, I'm new to HPC, but I am here to tell you more about the biological applications of HPC. So for SC20, we have GrowMax. So GrowMax is a versatile package for performing molecular dynamics. Even if you don't know much about molecular biology, so basically we have many different kinds of particles, and those that are most relevant to human or proteins, lipids, nucleic acids, and of course they have complicated bonded interactions between each other. So it is important to model them using Newtonian equations. So again, a lot of math equations involved, and which requires a lot of computational power. GrowMax can also be used for non-biological systems such as polymers. I also did a little bit more research on how HPC could be used, because there's definitely more that HPC could do. So the first thing I looked up is cancer treatment. So we all know that bioinformatics today is a big thing, and of course you need ground truth for that. So how are you going to get all the ground truth? You have to get accurate genomic data, which requires genome sequencing. So for now, the most reliable technology is the next generation sequencing, which requires parallelizing many micro scale reactions at the same time. So that is definitely one place where parallel computing comes into play. So I guess this is more biology because I'm a biomedical engineering major, but this kind of sequencing can output like 15,000 times as much data per day as a traditional sequencing technology. We also need the HPC for storing terabytes of information that we collected from different genomes. And personally, I'm interested in HPC because it has a huge implication in biological tissue simulation. Just imagine you want to study a piece of biological tissue, and the only thing you can model on the computer is to develop either a center-based model or a lattice model. So let's take a lattice model as an example. So imagine a 3D space which is divided into different grids, and a typical problem we want to tackle with is how, like for a single cell in that grid, do you have any neighbors? And you want to perform search. That's searching, and we know searching is a huge problem in algorithm development. So right now there's a project called Biodynamic Model Project. So this is a platform for biological tissue simulation, and HPC is really relevant in this context because in order to simulate the neuron activity, and we know that all the neurons fire at the same time. That is where parallel computing must come into play. Also, we mentioned that we want to search for the neighbors of individual cells, and that requires huge computational power for data structures like spatial trees, because when you want to detect your neighbor and even insert a new cell into your system, searching and insertion, at most we can maximize, or at most the best computational complexity is n squared or even n log n, but because you have so many cells in a grid, and also if you want to use more complex data structure like oct trees or R tree, which is not just binary tree, you would definitely need HPC to speed up the searching and insertion process. Yeah, and that's all about what I have for the biological applications.
Okay, so our last one is parallel programming with climate models, specifically the Community Earth System model. So this was created in around 1980s as both a freely available and low intensity global atmosphere model for use in research communities. Interestingly, it's also being used in a century-long experiment on the growth of carbon dioxide in our atmosphere that started around 1998. So project that to 2100 something. So CESM turns Earth's motions and processes, specifically the atmosphere, the land, the oceans, ice caps, into these discrete parameterized grid boxes using parallel processors. And, and our job for the competition is to design and build a cluster that can run several of the CESM tests and will be benchmarked by our completion speed. So from some preliminary Googling, we found that the applications are fairly CPU intensive. And as we mentioned before, we may not have the option of choosing our hardware. So we kind of want to focus our efforts into compilation. So what this means is that we want to find optimized compilers for the code base, which is mostly written in Fortran and C. We've actually already found some of them just from looking through various forums. And then in the event that we are allowed to choose our software, to choose our hardware stack, we're probably gonna go for SIMD, so that's vector, like optimized processors, specifically the AMD EPYC 7742, because that has great support for vector executions. So VJ, who was our club president a year ago, is now a graduate, is now doing a graduate degree at Georgia Tech. And the Georgia Tech undergraduate team is also applying for SC20. So hopefully that means in the fall, we'll both get in and we can have like a cool little reunion at a competition. Otherwise, thanks for having us. Hopefully we'll get to meet face-to-face soon and get to all know each other. Thanks.
Awesome, thanks. Do we have any questions for the student team?
So Benjamin, not that we're going to do this, but do you know if they're going to let us bring our own Azure credits with us and just like completely snow the other teams with tons of Azure credits or something?
I don't think so. They'll probably be providing a specific amount.
Yeah.
Yeah, but at least for preparing for the competition, if we do get in, I know BU already offers some free Azure credits, and just by having a college email, we can get 100 free ones. So hopefully that means we'll have enough to like set up our own test system and go through all the applications, see what we can do with them before the competition starts.
And is it kind of like other student competitions where you're just going to get a Linux? I mean, it's in the cloud, but it's a Linux box, and then you're going to have to stand up MPI and the libraries and all that. You got to do the full stack build.
Yeah, exactly. So because of the remote, it's pretty much all software we're thinking. So we kind of already figured we're going to use CentOS 7. That was going to be our OS regardless of hardware or software. And then, yeah, we found some MPI things, and then as I said before, optimized compilers. I think that's what's really going to make or break the system.
I had mentioned some of the prepackaged software. I don't know if you're going to have time to dig into this, but I know there are containers out there, for example, with GROMACS pre-built and optimized, and Spec and Easy Build definitely have recipes for GROMACS and probably the other software as well. I'd be curious if you do better custom building it yourselves or using the pre-optimized packages.
Are those in the link in the slides that you had for containers?
Spec definitely is. Easy Build isn't. So let me. I'll share some slides I'll share some links while we're talking here.
So in the past, NVIDIA used to give student teams a highly tailored LinPack binary. I guess those days are gone, huh?
Yeah, I don't know. I don't know if anyone maybe does Microsoft have the optimized LinPack for Azure? I don't know.
Yeah, as a binary.
It's a good question. And are you going to have access to GPU accelerated nodes, or you don't even know?
No clue.
Oh,
yeah, everything's completely new.
So it's
almost like we're walking in blind.
And how much notice do you have, or you have no notice? You're going to find out what kind of node you're on during the competition.
I feel like that's probably what's going to happen.
Wow. Okay.
They're probably scrambling to even get it all set up. So you can't ask for too much.
Yeah. Oh boy. Okay, I'm sending a few links here for you to take a look at.
Yeah, thanks a bunch.
Yep. And then, I mean, if you haven't used containers, I guess I'll send you a couple links there too. It's going to depend what you're working on though. Like if you end up with a container that has an NVIDIA GPU, you probably want an NVIDIA container, and if not, I'm not sure. Maybe you want something from the community. So there's something called Docker Hub, where it's like GitHub, right? Except it's for full software containers, and anyone can post something to Docker Hub. So you don't necessarily know what the provenance is, whether it's been built by someone who doesn't know what they're doing. But you know, you start searching GrowMax on Docker Hub, you might find some stuff.
Mm-hmm. What makes SPAC different from the usual package managers? Is it really just the HPC optimized?
Yeah, so SPAC and Easy Build are, I guess you could call them package managers, but they're source. So both of them take source packages and build them. And that could be, you know, from just a bare Linux box. It installs, you know, the Intel compilers and tools. It installs GNU compilers, whatever it happens to be.
Mm-hmm.
And then it'll build your MPI on top of that and all the libraries, OpenBLAS, LawPack, kind of everything you would need. So both of the tools will do that, and then they'll build your actual user application, be it GrowMax or whatever the application has to be. So they are compiling on that whatever you're running it on. So if you run it on Azure with a Cascade Lake processor, it's gonna tune the binary for that Cascade Lake processor.
Mm-hmm.
Versus a package manager where Red Hat built it on some random Xeon box, and it has not been tuned with flags for the particular CPU architecture that you're running on.
I see. Okay. Thanks, Elliot.
Yeah.
So it'll be interesting to see what the trade space is this year. I mean, when you've got a dozen schools showing up with their own hardware, it's a hardware competition. But when you've got a lot of people accessing the same cloud, it's going to be much more of a software engineering competition. So I wouldn't be surprised if some school figures out some way to build a monolithic stack that somehow optimizes the non-embarrassingly parallel parts of the code. I don't know. It'll be interesting to see what directions this goes. I know the ASC student cluster competition, that everybody has to use the same hardware over there, but you can go down to bare metal if you want. I mean, if you wanted to run, if you wanted to run Windows on their gear over there, they'd let you run native Windows. If you wanted to run some other operating system beside Linux, they'd let you do that. And I don't know if you'll be able to go down to metal on an Azure cluster, but it'll be interesting to see what people dream up for a differentiator.
You think you're going to have the freedom to play games with like going wide versus going deep, or scale up versus scale out, like one big box or a whole bunch of little cheap boxes? I know people will do that with Amazon, right? Where they get the what's it called? You can order preemptible. You can get a whole bunch of cheap preemptible VMs, and they might get preempted, but if they don't, they're cheap. I don't know how much flexibility you're going to get.
Yeah, back in the hardware stack, we were thinking of a 2-node system. Actually, I think we were gonna get one of the A100s, one of the NVIDIA A100s initially. But yeah, so I guess best case scenario is we basically just remake the 2-node system through Azure.
I think like one of the reasons that 2-node system might work best in this case for us, because like, to be honest, we don't know how the networking is going to be set up over at the Azure. So 2-node is very simple. Like if you have simple links, just node to node, or else like if you have 3-node or 4-node, then it becomes pretty complex, like how we're going to set up the networking, which we might not have control over.
You're right. You probably won't have control of the networking. I know Azure has some very robust systems available. The question, I guess, is going to be whether you get them. Right? They have InfiniBand enabled instances, but I guess you'll have to see what they give you.
Yeah. We might not even get. I mean, the thing is, we might not even get whole box. We might just get like some hardware off a VM, something like that.
Yeah.
So, yeah, we'll see.
Well, Kurt, a lot of times it's about managing your workload, isn't it? Even in the hardware only competitions, you still have to make sure you're planning your workload correctly, because you can't necessarily run it all in the allotted time. Is that still going to be a factor for these competitions?
Yeah. So certainly ISC, it's all very much, you don't get to make those decisions. That's a 9 to 5 conference. They shut the cluster off at night. But at SC, you traditionally do have to decide of the 5 codes, what do you want to do? You do some team strategy to decide whether you want to hit it out of the park on LinPack and do terrible on everything else because you've built around LinPack. Now, a lot of schools did that, and and they really do terrible on everything that isn't embarrassingly parallel. So as you can see, they kind of pick codes that stress 5 different layers of the 7-layer OSI stack, or you know, the Kvyat diagram for HPC. You've got an embarrassingly parallel code. You've got something that does streams. You've got something that kind of stresses matrix. We did that for a little while at HPEC. Do you remember the basically the embedded 7 code? I'll see if I can dig that up. The link, I don't think the link is still there, but the codes are still there on OMG Wiki. So I can dig that up. In fact, I'll probably do it before we log off. But they went out of their way to give you 5 codes that weren't all one type of acceleration, so that people couldn't show up with a dedicated cluster of DEC alphas and be able to just follow that path to victory on 5 codes. You generally had to do really good on 1 code and pretty well on 4 other codes. That's certainly been the Boston School approach for a while, is shoot for not center of mass, but slightly to the right of center, and doing you know, the benchmark codes, HPCG and HPL, definitely skew the score results. So you do have to do well on the benchmarks, and then accelerating the codes that change every year. Like these are some unique codes that they gave them. That is really your area that you can do some optimization and some novel tuning.
Okay. Anything else that people want to plug? I know we have a couple of events that are coming up for the Boston Meetup group, and we'll be posting links to that. So take a look. Any other events to plug? I know, Kurt, you had links to a couple of events that are virtual events that are coming up.
Okay, well, thank you all. I'm not getting any sound on here. Can you just check?
Yeah, I can hear you, Jerry.
Oh, okay. And Kurt, how am I coming through on the video?
I can see you okay.
Okay, good. I just changed some of the video settings.
All right. Well, thanks, Elliot. I thought we were going to have one of the other, the last team that went to a student cluster contest was UMass. They went to ISC last year.
Yeah.
And a lot of them have graduated. So I don't know if we can collect up on those. I don't know if you have any updates from them, but maybe I can get an email from them and find out how that went a year ago.
Yeah, no, I haven't. I don't have that. Yeah. Okay.
And the Northeastern students want to run their own competition, but they haven't been able to recover yet on their plans to do it either remotely or maybe just wait a semester. But they'll do that one of these days.
Yeah. No, running events is hard, but yeah, that would be fun to have a local cluster competition. I agree. Yeah.
All right. Well, thanks, Elliot. This was great. I'm glad we should do this more often. There's a lot of
Agreed.
overlap between I can see that there were a couple of computer architecture guys that sat in on this tonight. So there's a lot of overlap between HPC and Linux. So
Yeah, cool. Okay, agreed. Well, we definitely have a speaker lined up for next month in August. So I'll get that posted. And that's the student that was referenced down at Georgia Tech, VJ. So he gives excellent speeches. I definitely recommend you check it out next month.
yeah, and BLU has a speaker lined up for next month as well. The next couple months they've got speakers already well pre-advanced signed up at BLU.
Excellent. Okay. Well, yeah, again, thanks everyone. Hope you have a good evening. Be well.
Thank you all.
Thanks.
Good
Elliot.
night.
Good evening, everyone.
Thank
Good
you.
evening.
Thank
Thank you
you.
very much.
Bye.
Bye.
Bye.